Alright, section 3, units of measurement. Alright, many properties of matter are considered quantitative, meaning that they use numbers. They are used with numbers. A measured quantity of a measured quantity must have two things. It must have a number and it must have a unit. Numbers without units in chemistry are meaningless. They mean absolutely nothing. The units most often used for scientific measurements, especially in chemistry or all sciences, is the metric system. And we have what we call SI units, or the System International des Units. That's my French pronunciation, or the International System, the System International. We have 7 base units. These are considered our base units of the SI system. And we have several quantities that we measure with these base units. Mass, which is the amount of matter there. We typically use a triple beam balance to measure mass. Length, the base unit of length is a meter. We typically use either a meter stick or a centimeter ruler to measure the length of something. We'll be taking the lengths of some different things. Time, we measure with seconds. We use a watch or something to measure time. Temperature is measured with the Kelvin scale. Typically, we have to convert to Kelvin because our instrument that we use, our thermometers in the chemistry laboratory, use the Celsius scale, so we have to make a small conversion. You should easily remember how to do that. The amount of a substance there, or the count of a substance there, how many, we typically measure in moles. So if I have, when we're not dozen, we measure in like a mole. We can't say we have 12 atoms. That doesn't really make sense. So we say we have a mole of atoms, which a mole of atoms is 6.02 times 10 to the 23rd atoms. Quite a big number. That's how we count things in chemistry, is through the mole. And we measure electric current through the ampere, which we'll study a little bit this year, more so in physics if you take physics. And the luminous intensity of something is measured in the candela. Now, a different base unit is used for each quantity. Now, how do we distinguish between small numbers and big numbers in the metric system? Well, in the metric system, we use prefixes to convert the base units into units that are appropriate for the item being measured. For example, we would not measure the size of an atom in meters. You know, a meter stick is about the size of a yardstick. There are 10 yards on a football field. If we measured 1/10 that the size of an atom, that would be crazy. We know that a grain of rice is about 10 million atoms long. So what we do is we use a prefix to make those numbers either smaller or bigger. For example, we know that the base unit is just, let's for example use a meter. Now a kilometer means 10 to the third meters, or 10 to the third is 1,000 meters. Or centi, we know how to use a centimeter. If we're thinking about the meter, a centimeter is 1/100th of a meter. You should be able to look on a meter stick and count 100 centimeters. These Greek prefixes are used to change the magnitude of the measurement. Now let's talk a little bit about some of these quantities. Let's talk about volume. Volume is most commonly used to determine how much space something takes up. It is a three-dimensional measurement measured on an x, y, and a z plane, how much space something takes up. Everything has a volume. We have a volume. Our textbooks or our notebooks have a volume. The units we typically use to measure volume are liter or milliliter. Now, a liter is a cube 1 decimeter long on each side. 1 decimeter long on each side. The typical measurement, what we measure with in the chemistry laboratory, is the milliliter. Now, a milliliter is also known as a cubic centimeter, because a milliliter, if you take a milliliter and actually measure it with a ruler, you can measure out 1 cubic centimeter on each side. So you have a centimeter on each side of the cube. Now, volume, we can take the volume of several different things. We could take it of solids, liquids, and gases. Depending on how we are taking that volume determines which instrument we are going to use to take it. And I have several instruments here used to take measurements of liquids, or the volume of liquids. Now, we have a graduated cylinder, which is not the most precise instrument. Now, we have different measuring devices, have different uses and different degrees of accuracy. Typically, if we're working in one of our labs, we'll be using the graduated cylinder, which is not quite as accurate as we want it to be, but it works for most of our purposes. The syringe is typically used for measuring out measurements, so it's fairly precise. So it's fairly accurate. A burette is also very accurate. Remember last year we used these in titrations. Pipette and a volumetric flask. These are both very accurate ways of measuring things. These are instruments used to measure volumes of liquids. Also, we could measure the volume of a solid. How do we do that? Well, we take length measurements, or we can do what's called by taking the volume by displacement. We can displace water and get the amount of volume that it takes up. And we're going to actually practice this a little more in lab to make it a little more concrete to you. Let's talk a little bit about temperature. Temperature is the measure of hotness or coldness of an object, is typically what we refer to it as. It is actually the amount of average kinetic energy of particles in a sample. The more these particles are moving around, the higher the temperature is going to be, or the more energy or the more heat that you're going to create. We typically use a thermometer to measure temperature in our lab. You can also use like a digital thermometer or a temperature probe. But in scientific measurements, we use the Celsius and Kelvin scales. Kelvin, remember, is our SI base unit, and Celsius is typically just what we have to measure with. The Celsius scale is based upon the properties of water. You should remember on the Celsius scale that water freezes at 0 degrees Celsius and water boils at 100 degrees Celsius. Now, the Kelvin is the SI base unit. How do we convert to the SI base unit? Well, take a step back. The Kelvin scale is actually based on the properties of gases. We're going to talk about a little bit about that and their kinetic or their average energy a little bit later when we get to chapter 10. But it's based on the amount of energy that is in there. There can be no negative Kelvin temperatures. If your Kelvin temperature is even at 0, then all matter ceases to exist. So we cannot have matter existing at 0 degrees Celsius. 0 degrees Kelvin. Now, how do we convert from Celsius to Kelvin? We simply add 273.15. If you have a Celsius temperature and you want to go to Kelvin, you simply add 273.15. Now, what if you're trying to go back the opposite way? Simple, you just subtract. Now, the Fahrenheit scale is never used in scientific measurements. You should remember that the Fahrenheit scale, water freezes at 33 degrees Celsius and water boils at 212 degrees Fahrenheit. I think I said Celsius, but Fahrenheit. In order to convert from Fahrenheit to Celsius, for example, if we're taking the temperature of the room, or if I have my thermostat set on something, and we want to take the temperature or make a temperature conversion. If we're trying to go from Celsius to Fahrenheit, we simply multiply the Celsius temperature by 9/5 and add 32. That'll allow us to relate Celsius temperatures. For example, if I had a Celsius temperature of 25, do you really know, being an American, if that's hot or cold? Not really. So we have to make it sometimes relate better to us. Now, if we're using a measurement, if we have a Fahrenheit measurement and we want to figure out what the Celsius temperature is, we subtract 32 from the Fahrenheit temperature and then multiply by 5/9. And that's a little bit about temperature. Now, let's talk about a derived unit. Derived units are formed from the base units. So volume is a derived unit because we use 3 length measurements, and density is another derived unit. Density is used to characterize substance. Density is defined as the mass divided by the volume. Typically, we use grams per cubic centimeters or grams per milliliters for solids and liquids, or if we're working with gases, we use grams per liter. Now, This was originally based upon mass, and the density was defined as having a mass of 1 milliliter of pure water at 23 or 25 degrees Celsius. So at room temperature, the mass of 1 milliliter of water is typically 1 gram. And we're going to work a little bit with density this year.